Good evening and welcome again. This is my YouTube channel. So, before we start today, yesterday I told about the concept of the complex, type of complex. What do you mean by the chelated ligands? What are the ambidextrous groups or bridging ligands? Then, coming next, that means there are three important terms. First one is coordination number, which is completely it is depends upon the number of coordinate bonds bonded by a metal atom. In case, let us give an example. K4 FeCN whole 6. This is the complex, and in this part there are potassium is regarded as the basic radical, and in the coordination sphere part there is the central metal atom iron bonded with cyanide. That means cyanide as mentioned as Cn minus. Here is nitrogen as the donor atom. It is completely used as a negative ligand. Clear? Then coming next, that is the nitrogen atom of the cyanide completely 6 into 2, that is 12 number of electrons provided to the central metal atom. That is, there should be formation of 12 formation of 6 coordinate bonds with further donation of 12 electrons. That means it is clear that 12 electrons form 6 coordinate bonds with the central metal atom. That's why this is iron has the tendency to form 6 coordinate bonds. That means with 2, 6 cyanides. That is, the iron is the central metal atom. There are 6 coordinate bonds. That's why the coordination number here is equal to 6. It is clear that the number of coordinate bonds in a respective complex is known as a coordination number of the central metal atom. Completely coordination number of the complex in which present of the bidentate or polydentate ligands. Let us give another example. CO, it is cobalt, En whole 3. In the outside of the square bracket, I wrote about the Cl3. That means in this case, this is En. I have told in previous class that is En means this ethylene diamine. It is completely as a bidentate ligand. That means this bidentate ligand is attached with the cobalt. That means there are, you already know that one ethylene diamine contains two donor atoms. That means two nitrogens, and there are total number of 4 electrons. That is, these 4 electrons may form 2 coordinate bonds. 3, 1 En completely donate 4 electrons and forming 2 coordinate bond. Similarly, 3 ethylene diamine here forming 3 into 2 is equal to 6 number of bonds, coordinate bonds with the cobalt. That's why for a bidentate ligand, the coordination number here in this case 3 into 2 is equal to 6. Clear? If there is a tridentate ligand, 3 into 3 is equal to coordination number 9. If there is a hexadentate ligand, 6 into 3, that means coordination number is equal to 18. Clear? This is the concept of the coordination number. Then after then we have to discuss about the oxidation number. That means simply oxidation number. We have already simple in a simple case. If I write Fe2 plus ion, ferrous ion, or Fe3 plus ion, that is ferric ion. That means in these two ions are completely maybe exist as lower valency or higher valency. Somehow there are some charge 2 plus or 3 plus. Then you have to return it plus 2 or plus 3 state. There it is these are the oxidation state, oxidation number of the respective atoms. Then if in the complex case we consider, that is, take an example again, CO NH3 whole 6 after the square bracket, write Cl3, the use of the suffix. That means in central metal atom, NH3 is the ligand, Cl3 is the suffix. That is the acid radical containing negatively charged. That means in this case, nitrogen having 2 electrons, one lone pair of electrons, 6 into 2. That means there are 6 nitrogen atoms. Total number of electrons is equal to 2. There is formation of 6 coordinate bonds. That's why in this case coordination number is 6. Clear? Then coming forward, that is in this case ammonia, water, these are completely are called as neutral ligands. They have no any charge. That's why they have completely charge is 0. In this case, if we calculate the oxidation number, then simple formula, let us X be the oxidation number of cobalt, then plus ammonia as I told 0, 0 into 6 is equal to 0, plus chloride ion is written as Cl minus, that means minus 1. That's why it is completely tell us minus 1 into 3 ion, that means into 3 is equal to 0. Clear? This implies X here is equal to plus 3. This is the oxidation number of cobalt in the metal complex. That means there are some questions in the chemistry council exam, that is the oxidation number, calculate the oxidation number or calculate the coordination number of the metal atom in a respective in the following complex. This is the process. So the definition of the oxidation number is, it is the charge appears to have over an atom when it dissociates or associates into the respective compounds to form any compounds, or dissociates the compound dissociate into the ions. This is the charge, whether it is negatively charged or whether it is the positively charged. This is the charge appears to have over an atom, which is completely known as oxidation number. Clear? Then after coming next, that is another term, that is EAN, capital EAN. This is called as, the full form is called as effective atomic number of the metal atom, that is almost equal to the atomic number of the inert gases to the respective metals. That means it is not accurate 100% always. That's why it is completely rarely used in the coordination chemistry. So we have to calculate, there will be a formula of effective atomic number, that is EN rule. That means En of a metal, En of a metal, that is the formula atomic number minus oxidation number, atomic number minus oxidation number plus 2 into coordination number. This is the simplest formula, which is otherwise written as atomic number. We know that Z Oxidation number here taken as minus X plus 2 into coordination number written as small a. This is the formula Z minus X plus 2a. So whenever we calculate the oxidation number or coordination number, then you will go through the effective atomic number. Let us give an example. NiCO whole 4 nickel tetra carbonyl. CO is the carbonyl. Carbonyl is a neutral ligand which have charge is equal to 0. That means carbonyl present. Already you know that in the aldehyde cases or in the ketones cases. In here we can calculate En, that means atomic number of the metal atom, that is nickel 28 minus what is the oxidation number. Here cobalt is 0, 4 into 0, x plus x is equal to 0. That's why x is equal to completely in this case 0. 28 minus 0 is the oxidation number plus 2 into coordination number, that is coordination number. This is the neutral monodentate ligand. That's why there are 4 coordinate bonds with the nickel metal. That's why the coordination number is 4. 2 into 4. Total is equal to 36 is the atomic number of the krypton. This is the complete atomic number of the next inert gas. That's why this is called as the effective atomic number of the metal in a respective complex. I have discussed about the coordination number, oxidation number and effective atomic number in this video. Then coming next, in the next video, I will teach about the IUPAC names, how to write the IUPAC name or what are the rules of IUPAC name. Thank you for watching. Please subscribe.